ZESS is an abbreviation, actually a Center for Sensor Systems. We are a rather interdisciplinary research institute of the University of Siegen. We are really working very, very scientifically, very, very basic on remote sensing and in situ exploration. In situ exploration means that you get some information about an unknown scene from within. We do that by 2D, 3D exploration with our PMD camera, or you can do it from remote, from space, or from airborne platforms. This would be called remote sensing.
Radar with a synthetic aperture produces high-resolution images. From a carrier platform like a satellite or an aircraft, the SAR transmitter gives off short, frequency-modulated pulses. These signals, reflected back from the Earth, are taken up again by the SAR receiver and turned with complex algorithms into pictures.
When you get the SAR data from the receiver, you need to process them somehow in order to get a focus image. So somebody must modify this focusing algorithm, because if we don't modify it, we will get not really focus.
In contrast to classical photography, which needs reflected light, SAR works with microwaves. Since microwaves penetrate even the densest clouds, SAR is independent of the time of the day, of solar radiation and the weather. Even target distance does not play a role. The microwave image always remains needle sharp. While SAR technology establishes itself in numerous scientific areas, ZESS already advances a step further. Bi- or multi-static SAR generates, with the help of a number of SAR receivers, a 3D image, which now also makes information accessible about the height of objects photographed.
This is a 3D plots summarize the idea of the bistatic SAR. These planes represent the transmitter and receiver on different platforms, different planes. For instance, this represents the transmitter, and this represents the receiver, and this is the point target which we want to take the image of it.
Since transmitters and receivers use different carriers, the 3D enlargement of SAR technology demands highly complex algorithms for the calculation of the raw data. In order to exactly measure the absolute and relative speed of the sensors, different techniques are combined with each other. One of them is the well-known Global Positioning System, GPS. Within the framework of the improvement of measuring positions and acceleration, ZESS researchers look far into the future. It reminds you of the scenario from a science fiction movie. Recent experiments, for instance, deal with the evacuation from skyscrapers via parachute capsules. A metal case equipped with sensors simulates the fall of such a rescue capsule. It simultaneously supplies the data of speed and position.
Das ist unsere neue 2D-3D-Kamera, die mit einem speziellen Chip und einer modulierten Beleuchtung die Abstände in einer Szene aufnimmt und gleichzeitig mit dem zweiten Chip einfach ein zweidimensionales Intensitätsbild aufnimmt, und durch den speziellen Spiegel, den wir eingebaut haben, werden diese beiden Sensoren in der Kamera exakt übereinander gelegt, sodass Sie ein hochaufgelöstes 2D-3D-Bild einer Szene bekommen. Sie können einfach bestimmte Aufgaben aus unterschiedlichen Bereichen lösen, die Sie sonst sehr schwer oder nur mit mehreren Kamerasystemen lösen können. Das Beispiel ist Überwachungseinrichtung von Räumen. Sie können Ungenauigkeiten, die jetzt nur bei 2D auftauchen, durch die Information des 3D herausfinden und umgekehrt. Man kann auch ein anderes Beispiel nehmen, das ist, wenn Sie eine Person vor einem Hintergrund ausschneiden. Dann können Sie ganz einfach sagen, die Person steht vor dem Hintergrund, dann machen wir alles ab 2 Meter raus. Und da wir die Sensoren genau so aufgebaut haben, dass sie exakt übereinander liegen, durch den Spiegel, den wir da gerade auch eingebaut haben, können wir genau sagen, welches Pixel von dem einen Sensor zu welchem Pixel von dem anderen gehört. So ein Einzelstück ist teuer, aber die Komponenten sind von uns eigentlich so ausgewählt worden, dass sie eigentlich günstig sind. Also ein System in der Fertigung von unter 1.000 € ist eigentlich gar kein Problem. Ich persönlich würde mal vermuten, in den nächsten 5 Jahren wird es breitere Anwendung finden.
ZESS developed PMD camera, or photonic mixer device, is not only perfectly suited for processes of automation. In a way, it revolutionizes interaction between man and machine. Its ability to recognize forms like human contours can not only supervise safety areas. In ZESS, the University of Sigen's Center for Sensor Systems, machines are already navigated with a single wag of one finger. Medicine also profits by PMD technology. From planning stage to actual operations, surgery can be made easier and more accessible by ingenious combination of sensorics and robotics. Such surgical support systems are already successfully tried and tested.
The systems comprise also a force torque sensor, which is the interface that the robot used to get the applied forces from the surgeon, and that go to the computer, a real-time computer, which processes all the information, and there are all the algorithms implemented in order to build these virtual constraints, and so the robot can react and as desired.
Terahertz technology is of inestimable value in diagnosis and treatment of certain diseases. Physically situated between microwaves and infrared, terahertz radiation makes optically dense materials transparent. It can not only be used for the analysis of genetic material, but it is also an ideal means for scanning clothes to detect arms or explosives. In addition, it is suited for quality control and wireless transmission. As promising as this new technology may be, working in terahertz frequency is a difficult undertaking. Nevertheless, ZESS, by its early research in this field, still has a worldwide lead.
The IPP stands for International Postgraduate Program. It is a doctoral program comprising 3 years, where you start as a master or a diploma engineering, and then you work towards your PhD.
I think working conditions are quite good, and colleagues and the other people around, they are quite helping.
What I really appreciate is the support of the ZESS staff. I mean, not only the professors, but all the colleagues. Each single colleague is always willing to help each other. We are not competitors with each other. We work in different things, but we always work at once if necessary. So I really appreciate the friendship or the good understanding between each single colleague.
We have a very, very thorough selection routine. They write their application. Based on that application, we have a pre-selection, then we invite them for an interview. And after the interview, we invite them for an on-probation period of 6 months.
If you are serious and you have good motivations and you are hardworking, then I think you can, if you have favorable conditions, then you can manage it.